Hi, just a quick heads up. This video is split into 3 parts. It became quite long and I wanted to keep it shorter. Hi, as usually I'm Niels and I'm back, and as usually we're going to write the parser for our programming language. So far we have left our function bodies empty. We are going to change that. And we are first going to look at what kind of content makes up our function bodies. And we're slowly going to create that content. So let's just dive right in. We have our function bodies here. This is the struct for it. I will just refactor this at this point into a new file because I think that time has come. So let's just grab this here. Make it public. And yeah, now we have our own file where we can just, play ever so slightly. I seem to have accidentally deleted my keywords. Okay, this is a bit weird. Right, okay. Everything's back to normal now. Okay, how frightening, really. Yeah, we do care about this. We do care about function bodies a lot, and right? Because otherwise we get nothing done, really. And I am going to make some unusual decisions here. For the sake of structuring my own mind. And this unusual decision is that I am not going to allow embedded functions, right? But instead gonna allow later on lambdas to be in our language. So but that's just one thing to make things a bit easier. Right. Let's have a look what function bodies can contain. We see there are expressions here, like function calls, and function calls can be nested recursively, and they can have arguments, right? There are literals, meaning you have just, in this case, it's the constant for the bool value, but this, in theory, could also be, just the argument returned, and then we would have to need to be able to parse this still. We can have let statements and we can have return statements, and there is a difference between statements and expressions. But I am sometimes probably going to mess up the wording here. Of course, that's not everything, but let's just see in future episodes I will take care of parsing numbers correctly, because there's so much about it. Strings, oh dear, I think this should be multiple episodes even, because strings they have to be escaped. There might be string interpolation, which I think is really cool. I want this, and I want to show how one would go about this, because it's a bit complicated. And then we have control flow. I want if and else to be an expression in the language. But of course, there's more control flow. We have loops and everything, but we won't care about all of this right away, because you can get lost in details before you actually have anything on hand. And I really want to get to the stage where we can, run our programming language and then build up on that and create new features and actually see them working. One of the things I absolutely do want in this language, which is a bit hard to do, and it's very much deserving of at least its own video, is how would we in our system parse recursively and with proper precedence mathematical expressions, right? In this case, this, for example, would be we definitely want in this case the 8 times x to be evaluated first, right? Unless, of course, it's in parentheses. And there's mathematical expression parsing. It's non-trivial, I'd say, and we will do it later, just because it's a bit of a behemoth. It's not hard once you get it, and it's a lot of fun. But for now, let's just get something to work. And we have something to work if we have basic function calls. We will create built-in functions if we evaluate this for stuff like print, and if we can return stuff, if we can print stuff. By the way, this is, why would I return something that is printed? I might really just return this. Return statements. We have, we see sometimes expressions, they can be, without anything, without being, just, being called, without being assigned somewhere, like in, the let statement here. All of that is for now enough. So function calls, literals, let expressions, or let statements actually, sorry. That should be quite a bit for now. But it's a lot of fun. And it's going to be even more fun. So what we can see is, maybe it's just that, but okay, I don't have this, but we can have multiple let statements, multiple calls that might be not really needed, and we can return whatever we want. That's quite interesting. So what actually is an expression? Literals are an expression, function calls are an expression. Cool. Let statements are expressions. Return statements aren't expressions. They're statements. So, maybe we should start with that. Create statements. Create expressions. I will make the font size ever so slightly bigger for now, just for now, and see how that is. And we will implement this for now. There's the return expression. Nice. What else? All right. Here's the let expression. Actually, I want this to have like a name. The name is, some identifier, some string, and the value is, of course, some expression, really. Okay. Other than these statements, what do we have? The expressions, right. I'm gonna start with a function call. I think that's quite interesting. Right, we see it's recursive and it has like arguments. There's something about recursive stuff that's really satisfying, but you need to keep some stuff in mind. It's okay. But, yeah. Function call has the function, which actually it's an expression because that is, for example, valid. Or later on we want something like this to be true, right? But at the same time, right, I mean, x is just some value. We want to be able to return x as a closure. It's a bit confusing why this should be an expression. But if we resolve this, we want to look up what this symbol hello actually means. And we also want to look up what, for example, num means. And num might just be a closure here, which, we could call. So, there might also be some, that would be fine as well, syntactically. So yeah, the actual function, that's an expression. Arguments, that is a bag of expressions. I am having fun. Now we get to the point. It's so fun. We are working in Rust and we have just created an impossible type. This is impossible to construct. It's just not possible. Because the expression is infinite. If we would try to create this, we would just have, it's logically nonsense. And it's so easy to get around this. It's just we box our expression and everyone is fine. Right. With this little piece of code, we can already model this data structure. Now let's get into this. There might be literals. Right, and we have a lot of literals. For example, the bool literal, number literal, which we don't have to do this like this. I mean, we could technically also do it like this. Right? And that would be fine, that would be enough. But I don't want to. It's just this. I'm going to overcomplicate this. I want to have a bool literal, and that the value is a boolean. On the same, note, we might have a number literal and have this as an I64 or anything. If you're writing a parser and get to the point of numbers, I will repeat this later, but if you get to the point of numbers, you might actually want to consider not saving your numbers as numerical value, but as a string value, because during parsing of the strings, you might have overflows and everything. But we don't care about this, again, because we just want to get forward. And, for now, we have the bool literal. I'm fine. We have identifier, which is a string, right? This is an identifier. This is getting exciting. I think we're mostly done. Woohoo! I think we're mostly done. And again, we could save that bool literal and by just having like the literal, having the ident called false. Right? We have like this. That might save us some trouble, but I don't want it. Because I want to use the, one reason is that I want to use the JavaScript syntax and language server for as much as I can. And at some point I will derive, because JavaScript isn't really the nicest language, but for now just, we keep it that way. Okay, I guess I'm a bit overly excited, but it is going to be fun. Okay, let's get right into this. We have everything we really need in place. Okay, but we still need some. Oh. Yeah, right. False, for example, that is a keyword. And there's a problem with that. And the problem is that if we apply our current situation of parsing keywords, and we have something like false 8, which of course is not a keyword anymore, or keyword parser would recognize this. Like if we have something silly like that, that would actually fire. So we use another macro called keyword terminated, and it's just applying another parser after that. And let rest not. Oh, I thought I have this, so maybe the best idea really is to write this all out for now. I'm starting now with parsing the false keyword, and we don't want this to be recognized as a keyword, but we want this to be recognized as a keyword. So, come on, buddy. Oh, I think that's neat, really. Here is num combinator not, and we do not want this to be followed by any alphanumeric character, which would mean take us not the right alpha 1. Just see. No. Maybe we could take RMM. Take while and then from 1 to 1, and the condition really, that is a bit simple. I think we have an utils, maybe, or identifier. No, okay, we have identifiers actually, but we have it in main RS still. And identifiers were quite simple here, and that is it's just this. And the clever way would be to have a bit of code refactoring right here, but for me that is okay. We want the second part of the identifier, not the first one, to be our condition. So